This is the final naming video in my series of namings, and it's the naming of acids and bases. Now, naming of bases is very simple because you just name it as you would any polyatomic ionic compound. The naming of acids, though, I'm not sure what people were thinking, but they made it a little bit complicated. So today I'm going to teach you how to name with acids. I got these notes from Pearson Chemistry, so I need to give credit for these next section to Pearson Chemistry. Here are the 3 types of acid naming rules. What is an acid? For now, just know that an acid is basically anything that starts with hydrogen and produces hydrogen ions when dissolved in water. You will have whole sections devoted to studying acids and bases. So the general format for an acid is HNX. It starts with an H, and if it's added to water, it's going to give off an H plus ion. All right, so let's start with the first type of acid. In the first type of acid, it says when the name of the anion, what's the anion? So let's write HCl right here. When the name of the anion, Cl would be your anion, ends in IDE, well, Cl would be chloride, so it ends in IDE. The acid name begins with hydro. The stem of the anion has the suffix "ic" and is followed by the word acid. Oh my goodness, that sounds so confusing. What are they saying? They're saying, okay, I have a binary acid, HCl. This Cl ends in IDE. So we're going to start anything that ends in IDE on its own. Originally, we would call this hydrogen chloride. But it's an acid, so we want to give it its special acid name. So we're going to start it with hydro. Then we're going to do the stem of chloride. We're going to call it chlor. And then we're going to give it an ic. And then acid, hydrochloric acid. You're like, oh, well, what's so bad about that? I've heard of that before. Yes, you have. Hydrochloric acid, muriatic acid, or pool acid. Let's look at the rule again. When the name of the anion ends in IDE, the acid name begins with hydro. The stem of the anion, in other words, the chloride, becomes chlor, and then it gets the suffix ic, hydrochloric acid. All right, so here's 4 sample problems. These are all binary acids. They all have H and an anion. The anion all ends in IDE. In other words, if I was going to name this would be hydrogen fluoride. This would be hydrogen chloride. This would be hydrogen bromide. This would be hydrogen iodide. I'm so sorry, iodide. Okay. So these guys all end in IDE. So it's a binary acid. They all end in IDE. So we're going to start them all with hydro. Then we're going to put the stem name in the middle, give it an ic, and then say acid. So here we go. This first one, the stem name is going to be fluor. So it's going to be hydrofluoric. Okay, so let's look at HF again. The stem of HF is fluor. So we're going to put fluor in here. And this thing is going to be called hydrofluoric acid. Let's look at this one, Cl. The stem of Cl is chlor. So we're going to put chlor in here. And what's it going to be called? Hydrochloric acid. You try these last 2 on your own. And yes, number 3 is going to be hydrobromic acid. And the last one sounds very funny. It's going to be hydroiodic acid. Look at those vowels. Hydroiodic acid. And those are your most common binary acids. So you may say, well, it's just easier to memorize the name than memorize the rule. Whichever way works for your brain is the way that you need to go. Okay? So now let's go on to the second type of acid. In the second type of acid, when the anion ends in "ite," you change the ending to "us." and you do not start with hydro. So when the anion ends in ite, you change the ending to us. So for example, this comes from sulfite. So the name is going to be sulfurous acid. There's no hydro anymore. Okay, so when the name ends in ite, forget about the H. You recognize the H, it tells you it's an acid. Change the ending to us and only use this guy to name it. This is sulfite, so it becomes sulfurous acid. All of these, the polyatomic anion ends in ite. This one here is nitrite. This one is sulfite. And this one is chlorite. So what you have to do, though, is you have to be very aware of what's going on. Because you may want to call this guy here hydrogen nitrite. If your teacher asks for the acid name, then you've got to follow the acid naming rules. So this hydrogen nitrite, it ends in ite, so we're going to give it an us ending with no hydro. So this guy is going to be called nitrous acid. Okay? This one here, you may call this hydrogen sulfite, and you wouldn't be incorrect unless your teacher wanted you to give the acid name. Okay, so you're like, there's the H, tells me it's an acid. The anion ends in ite, so this is going to be called sulfurous acid. And then this last one, you may not have seen this anion before, but this anion here is the chlorite anion, ClO2 minus. There's the H telling you have an acid, so this is going to become chlorous acid. Our third acid rule says when the anion name ends in ate, the acid name changes to ic, the ending, followed by the word acid. So nitrate becomes nitric acid. So let's do a few of these. So it's the same rule as number 2, except in number 2, if it ended in ite, you give it an us ending, and in number 3, if it ends in ate, you give it an ic ending. And I've come up with a saying, and I say, she ate ic and got bronchitis. She ate ic and got bronchitis. And I can't tell you how many times I sit there and I'm like, nitrate, she ate ic, nitric acid. Nitrite and got bronchitis, nitrous acid. Now you notice, before I had HNO2 over here, now we're going to do HNO3. I had H2SO3, now H2SO4. HClO2, now HClO3. What we're doing is we've added on an extra oxygen, and these all have 8 endings. So this is a nitrate anion. This is the sulfate anion, SO4 2 minus is sulfate. This is the chlorate anion, and this is the phosphate anion. Those are all polyatomic ions. So these all end in 8. Let's check. 8, 8, 8, 8. So you're going to give them an ic ending. So nitrate, she ate ic. Nitric acid, no hydro because it's not binary. Sulfate becomes not sulfic but sulfuric acid. Chlorate, chloric acid. Phosphate, not phosphic but phosphoric acid. Some students say these naming rules are too confusing. I'm just going to memorize the common ones. You can do that. It depends on how your brain works. I'm not a good memorizer, so I remember the rules and apply the rules. Now, what about naming a base? You'll be glad to know that naming a base is easy. You've already done it. And it's just literally naming the metal with a hydroxide ion. Because a base is generally an ionic compound that produces hydroxide ions when dissolved in water. And we already learned about hydroxide ions in video number 2 of naming, and that's the OH minus ion. So what's this guy's name going to be? It's going to be lithium hydroxide. Lithium hydroxide. It's a base, produces these OH ions. How about this one? Sodium hydroxide. Sodium hydroxide. No fancy names, no fancy mnemonic devices, just name it as you see it. This one, potassium hydroxide. Potassium hydroxide. All right, now what about if they give you the name of the base and you're told to write the compound? Well, you just follow the same rules that you learned in video 2. Beryllium, look on your periodic table, it's in a group 2, so it has a +2 charge. Hydroxide, O negative, it's hydroxide. Okay, now I've got to balance my charges like before because this is an ionic compound, O negative. So this is going to be +2 -2, so it's going to be Be 1, 2. 2 of them. So I have to put the OH in parentheses to show that I need 2 of the whole thing. So beryllium hydroxide is going to be Be parentheses OH2. Why didn't they put the parentheses here around the OH? They only needed it once, so it's unnecessary. How about calcium hydroxide? Well, calcium is also in group 2. So +2. Hydroxide, O negative, it's hydroxide. So I'm going to need 2 of them. Oh, I want to just play the switcheroo game. If this is -1 and this is +2, I put the 1 here and the 2 here. Now be careful, you don't show the 1, and then the 2 needs to apply to the whole hydroxide, so you put it in parentheses. Let's try one more. What about aluminum hydroxide? Aluminum hydroxide. Well, aluminum is in group 13, so it has a +3 charge. Hydroxide is O negative, it's hydroxide. Let's play the switch game again. 1 there and a 3 there, so it's going to be Al1 OH3. But remember, you don't show the 1, and the 3 applies to the whole OH, so that's aluminum hydroxide. And folks, you just learned how to name bases in about 3 minutes. Congratulations. Now, to finish off this section of naming acids and bases, I've listed, let's see how many, 18 of these. If you see the name, write the formula. If you see the formula, write the name. Okay, so I'm going to show the first 10. Let's do these first 10. Pause the video and then you write the answer. Remember, if it has an OH, it's a base. Just name it with hydroxide, and then the acid, you've got to apply those 3 rules. All right, let's look at these answers. Sodium hydroxide, that's a base, so I'm just going to do Na+1, OH -1 is NaOH. Done. Sulfuric acid, so I'm going to tell myself she ate ick and got bronchitis. So sulfuric acid, that means it comes from the sulfite ion. Sulfite, oh my goodness, this is hard. Sulfite is SO3 2-. It's an acid, so it needs an H. And I've got to balance my charges, so I need another H. So this is going to be H2SO3. That was hard. They told me sulfuric acid. Us comes from the ite. You've got to know what sulfite looks like. This is sulfite. And then you got to balance enough H's to balance out the charge to give you H2SO3. We're going to skip number 3 for now. Let's go on to number 4, phosphoric acid. She ate ick. So phosphoric comes from phosphate. If you look at your phosphate ions, PO4 3-. So I'm going to need how many H's to balance out that 3-? I'm going to need 3 of them. So phosphoric acid is going to be H3PO4. Okay, we're going to skip number 5 for now. Skip number 6. Let's go on to number 7. Calcium hydroxide, CaOH2. I just explained that one. Number 8, iron 3 hydroxide. That means Fe plus 3, OH minus 1. Let's do the switcheroo game here. That means I have a 1 there and a 3 there. So it's going to be Fe1, OH3. Put it in parentheses to apply it to the whole OH. Get rid of this 1, and there that is. Okay, here are the ones we skipped. Number 3, hydrosulfuric acid. Number 6, hydrocyanic acid. And number 9, hydrophosphoric acid. Okay, those are the binary ones that start with hydro and end in ic. It comes all the way back to this first rule right here that we learned, okay? So let's look at it. It sounds so complicated, but it's not as complicated as it feels. Hydro, it's an acid, so it needs an H, at least one H. Sulfur is in group 16, so it has a -2 charge. So I'm going to need 2 of my H's, so this one's going to be H2S, hydrosulfuric acid. All right, so let's just look at this quickly. We have this, and this. This is sulfuric acid. How do I know? It comes from the 8 ion, she ate ic. What is this one? This one is the sulfite ion and got bronch-ite, so this is going to be sulfurous acid. And then this one has, it's not polyatomic, it's binary, so this one's going to be hydrosulfuric acid. Oh my goodness, so much to think about. It isn't easy, and it just comes from practicing. So if it's overwhelming, you're not alone, but it comes from practice, okay? Let's now look at this hydrocyanic acid, number 6. Okay, so the cyanide ion, if you look it up, is Cn minus. Hydrogen, hydrocyanic acid would be HCN. Hydrophosphoric acid, this comes from phosphorus. Phosphorus is just a P. P is in group 15. It has a -3 charge. So if I just play the switcheroo game, this is going to be H3P. Hydrophosphoric acid. So do you see what I named? I did my she ate ic and got bronchitis. I did those ones first. Then I came back and named the ones with hydro because I had to think a little bit more clearly about those. And sometimes when you jumble them up all together, you get confused. Now let's try and name all of these acids and bases. So you're going to pause the video, try and name them, and then we'll come back and go over them together. May I make a quick suggestion though? Go through and find all the hydroxides and name those first, because those are your bases, which is way easier than the acids. Okay, let's go through and let's name the 3 bases. This one's going to be lithium hydroxide. This one's going to be cobalt hydroxide. And cobalt might be multivalent. I'm going to go ahead and put a 2. Because if this is -1, there's 2 of them, so -2, so this would be +2. And this one is going to be beryllium hydroxide. So those are your bases. Let's go through now and let's find any binary acids. Those are the ones that are going to have the hydroic acid. There's one. So it's H with a single element. There's H with selenium. There's H with Br. So these 3 are going to be your hydroic acid. So this one's going to be hydro, fluorine, fluoric acid. This one's going to be, this is selenium, hydrocyanic acid. This one, bromine, hydrobromic acid. Okay, now let's look for any of our polyatomics that end in ate, because she ate ick and got bronchitis. Okay, so this is carbonate and this is sulfate. So these two are ate endings. So she ate ick, so this is going to be carbonic acid. She ate ick. And then this one here, ate, is going to have an ick ending. So this is going to be sulfuric acid. Now we've got one more sitting here all by himself. Okay, this is nitrite. Nitrite. So that has an ite ending. So ite, she ate ick and got bronchitis. So that's going to be nitrous acid. This is not for the faint of heart, folks. So if you got a few of these wrong, go back and rewatch the video. And once you nail it down, it will get easier and easier. But it's a little overwhelming at first. Well, congratulations. Now you know how to name binary ionic, polyatomic ionic, multivalent ionic, acids, and bases. There's one section left, and then you're done, and that is naming covalent compounds.